An important topic in our unit is comparing volumes of different shapes and what relationships they have. So the first example we want to look at is what happens when we compare the volume of a cylinder to that of a cone that has the same height and the same radius. So if you go ahead and make up your own numbers for height and radius with both of these formulas, go ahead and compare your answer, and what do you find out? So just as a review, the volume of a cylinder is going to be the radius squared times the height times pi. And the volume of a cone is going to be radius squared times the height times pi divided by 3. So go ahead and create your own h and your own r, calculate the volumes, and compare the difference. Not the difference between if one volume is 600 and the other is 200, the difference is 400. Compare how many times greater one is from the other and see what you get. So go ahead and write your answer on the line here. So what comparison can you make when you made up your own numbers for radius and height? How much different is the volume? Additionally, think about if a cylinder was filled full of water and you poured it into the cone, how many times could you fill up the cone? So we have to understand that the cylinder is going to have more volume than the cone. So how many pours would that be? On the other side of this, if we think about if the cone is full of water, how many times would a cone fill a cylinder, right? So these are the same kinds of questions asked differently. And this is the same relationship you'll get from up here. So go ahead and calculate that on your own and see what you come up with. We also want to make the same comparisons for prisms and a pyramid that has the same height, length, and width of the bases of, so the same base dimensions and the same height. So the same base dimensions of the prism and the same height. Again, the pyramid dimensions are the same. So how does that compare? Again, the volume of a prism is the area of the base times the height. And the volume of a pyramid is area of the base times the height divided by 3. And then go ahead and answer these questions. So what comparison can you make when you made up your own numbers for length, width, and height for both of those shapes? Try to figure out what numerical value you can come up with. If the prism was full of water and you poured it into the pyramid, how many times could you fill up that pyramid? If the pyramid was full of water and you poured it into the prism, how much of the prism would be filled with water? So again, make those comparisons with those numbers, because the answers to these are the comparison answer for the very first question. A couple more examples to think about. In this example here, in this picture, we have stack A and we have stack B. In both of these are both prisms, right? They have a rectangular base and they have a height. And this is, it looks different, but it's really not. It has a rectangular base and the height, which happens to be this way. Remember, the slanted height is called the slant height. So in this case, they both have the same height and base. So how do the volumes compare? Think about it, right? If they have the same base and the same height, how are they going to compare? In this example, it looks like there's sheets of paper. So would the amount of papers in this pile differ from the amount in this pile? One other example to think about to finish this lesson, if you had two cylinders with the same radius but different heights, how would the volumes compare? For example, if one cylinder had a height of 3 and the other 15, how much more volume would the taller cylinder have? Go ahead and calculate that and see what difference you get. Again, don't compare overall answer, compare the difference in the answers. Is it twice as much, 3 times as much? Okay, use that as your comparison for not just this problem, but all of these problems in this particular lesson.